the older I get, the less I know. Do you ever feel like that? You guys that are young, live it up, because it feels like you know a lot, and as you get older and older, you just start to realize that you're not as smart as you thought you were, and that's kind of where I am in my life now. I actually have two jobs. I have my university job where I preach about water wherever I go. I also have a regular preacher job where I preach about God. And I can tell you one thing, it's easier to preach about God than it is about water. It's a lot easier. And sometimes I feel like I know a lot more about that than I do about water. There is so much unknown about water. I've enjoyed the speakers that came before me, and I was just jotting down some wisdom. And RN talked about change, and we're in the middle of change. We are. Whether you want to change or not, you're going to change. I wrote down that it's not our intention to offend anyone. It's not my intention to offend anyone, but sometimes the truth is offensive. Just these past 2 months, I've been going to different counties and giving similar type presentation and talking about drought and everything, and it's kind of bad news. Drought is hard to deal with, especially when you look at our history, and that's really I'm an agriculture engineer, and you heard all that garbage about everything that I've done, and it's like, really what it says is I couldn't keep a job, so I kept bouncing around. That's what I've done, and I've learned over time that I'm not as wise as I think I am, and if you guys think about it, you probably understand that none of us are as wise as we think we are. There was another quote here, we respond to money. Isn't that the truth? Barry said when you're counting on rainfall, you have to have some faith. That's the truth too. You got to have a lot of faith. I have a couple quotes for you. They're not my quotes, but I'm going to be talking about, well, we saw the video about the plow and breaking out and everything. There was a belief back then, a firm belief that rain followed the plow, because it happened. They went out and they plowed, and here came the rain, and it's like, hey, rain does follow the plow for a while. There's also a quote, the outcome of a rain dance is entirely dependent on timing. You've probably heard that before, but it's all about timing. I'm going to talk about timing a little bit. This little tyke up here is he was 3 years old. He's four now, closer to 4, but he lives, they live in Massachusetts. My son-in-law is a pastor, and that's where he is, and I wish they'd move closer, but that's where they live. But last summer he was out and he wanted to water the truck, and so I took this picture. But I started thinking, what's life going to be like for him 20 years from now? Barry was talking about it. What's life going to be like 20 years from now? It's going to be different. It's going to be change. And we're hardy people. We really are. You heard in my bio, I've tried to move away from Texas Panhandle. It just doesn't work. I keep coming back. It's the people. We're hardy people. We're hard workers, and we will adapt, but we will adapt to change. There's no doubt about it. I'm going to talk about just dealing with drought, declining groundwater, two bad news things. And then I've got a little bit of data too, if I have time, which I think I will, talk about some of the research that we're doing here at the university. I don't have to tell you, but our lifeblood has been groundwater. And we started, you see that picture on the right, 1913, 1920s technology, we learned there was a lot of water in the ground. So what did we do? We started pumping the heck out of it. And we had, when it first started, we had these wells that were like, 1,000 gallon a minute well. And we thought it would last forever. And so we pumped and we pumped and we pumped. This is a picture, and I'll talk about this guy, Don Green. He's got a book out called Land of the Underground Rain. It's really history, but it's very interesting. Our groundwater's been dropping. We hit a peak in about 1999, 2000 with the amount of water that we were pumping. We rode this ski slope up, technology and wells and center pivots, and we're on the slope back down. We changed going up, we're going to change going back down. Northernmost 15 counties, so where I spend most of my time, I'm an irrigation engineer, and it's hard to be an irrigation engineer in the South when you don't have any irrigation, right, Barry? It's just hard, and so I spend most of my time up with the guys in the North who are still trying to farm corn. We've seen about a 25% decrease in ability to pump in the North in the last 25 years, predicting the same amount of decrease in the next 25 years. In the South, I was reading that they're predicting a 56% decrease in the next 25 years. And the guys in the South say, how can that be possible? We don't have any to start with. How can you have 56% less? But that's the statistics for you. It's just a graph, some data from the northern counties. Again, just talking about that 25% decrease. And they're at a point now, on average, where they don't have enough water to grow corn on the whole pivot. But they're still trying. And they're asking questions like, how should I transition as I go from, I've been so successful in growing corn for 20 or 30 years and made lots of money. But then 2011 came along and got a big eye opener. Everybody got a big eye opener. Every county that I go to, I pull up a map of just from Google Maps, just an aerial photograph. And I was up at Drought last week and showed them this is what north and east of Drought looks like. And there's a lot of pivots. And it's obvious there's a lot of water. And you're starting to see some split pivots and that kind of thing. But let me show you the difference between Drought and I was over at Dimmitt. And you see things like up there on the top, that almost looks like Barry's place. I know it's not, but you're seeing instead of the whole pivot, not even half a pivot, it's just partial of half a pivot. That's the change that we're dealing with. And I tell the guys in the North, if you want to see your future, look to the South. That is the truth, but I'm a bad guy for saying it. But trust me, 20, 30 years from now, the northern counties are going to look like the South. What's the South going to look like? It's going to change too, there's no doubt. I like data. Barry said he likes graphs. I love graphs too. This is a plot, a bar chart of what I call growing season precipitation. It's precipitation June, July, and August. So the sum of June, July, and August for the last 129 years from 1895. And when you look at a graph like this, you hear, and we're here in Randall County, our average, long-term average for those 3 months precipitation is about 8.5 inches. And you go, well, hey, that's pretty good, I like that. But then you look at the variation from year to year and you go, oh my gosh, this is not really what I expected. And we know it, but we don't know it. We don't pay attention to it until 2011 comes along. Look how variable that is. No wonder it's hard to farm here. You either got too much rain or not enough. If we had 8.5 inches, you guys that are farmers or producers, if you could count on 8.5 inches every summer, wouldn't life just be grand? It would, but that's not what we have to deal with. As a scientist, I'm kind of interested in the long-term trends, because you can't even turn on the news without hearing about climate change and global warming, and worse than that, it's people pointing fingers at each other for the cause, and it's because you're driving that big diesel pickup, or it's because you're eating beef. It's something. Fingers are pointing at us in agriculture. Falsely, I think. Why don't we just stop then? We'll just stop feeding the world and see how they like that. I think they'd have a different perspective. But if you look at the long term, there has been a small decrease. If you look at the linear trend there, it's kind of going down in the last 129 years. It has decreased a little bit. But the short term, year to year variability still far exceeds any long-term. We can't blame everything on climate change. We got to deal with the ups and downs of every year. Now this is a little bit different story, but the same. This is temperature. So average temperature over the June, July, August. And there is a trend going up. I'm not so sure that I'm going to argue that it's climate change caused by agriculture or enteric methane emissions from feedlots. Or even driving our vehicles. There's a lot of people that go and they do a correlation between this going up and CO2 going up. And they say, well, it's caused by CO2, and we need to decrease it. I learned early on in statistics, just because something is correlated doesn't necessarily mean that there's causation. And when I was teaching statistics, I would give examples, and I would show a correlation between ice cream sales and shark attacks. And it would great linear correlation. And so I'd ask my students, well, what do you think? Well, does that mean if you eat ice cream, you swim slower? So maybe, or maybe you taste better? No, it's correlated through a third factor, which is people go swimming when it's warm. And they also eat ice cream when it's warm. Not very many people, I don't really crave ice cream when it's in a snowstorm, but I crave it when it's 100 degrees out. That just to say that maybe there's something going on, this is just my personal opinion, but we've had climate change forever and ever. I was reading a book just the other day where they were talking about they have found in Greenland, so I have to remember this, Greenland is ice, and Iceland is green. But Greenland is covered by ice now, but they have found evidence of farming underneath the ice, which tells me that a long time ago, it was a lot warmer then. And that's one thing we know. I'm preaching about climate change now. Don't believe every bit of science that you hear, including from me. You guys got to make your own. But there is statistically, it's getting a little warmer. I want to go back to this precipitation graph. See that circle there on the right? That's 2011. And everybody, that was in the news. It's climate change and people pointing fingers and all this stuff. But if you look back 129 years, which is how long we have weather data, if you look back, you see that that's not an anomaly. 2011, I wish it was. I wish I could tell you that that was an anomaly and we'll never ever see it again. But if you look back at the history, there's a lot of times when we've had drought. It's part of us. Drought is part of us. We live in the desert. We try to farm, and we've been successful at farming because we've had groundwater, but we live in the desert. I've got the Dust Bowl, the Dirty 30s. We saw all those pictures. I hadn't watched that video, by the way, and that was very interesting. But the Dust Bowl, and everybody is kind of, you hear, well, it was the plow. It was the plow that called it. It was the combination of plowing plus drought in 3 or 4 out of 6 years. It was drought. Basically what we had was we had 2011, only we had a few years strung together. There was a time in the 50s also. You see that square 1955-60. It's not that low, but the thing was there was 4 or 5 years that were strung together. That's what hurts us when we get those things strung together. All the way back into the 1895s. Now, I want to read something to you, and I did not write this. Actually, this came out of a newspaper in Tascosa. Do you guys know where Tascosa is? Boys Ranch. If you go from Vega north to Canadian River, right there. It's just Boys Ranch is all that's there. But this came out of the newspaper, and this actually came. I was talking about Donald Green's dissertation. Donald Green got a PhD in history, and so he wrote this dissertation, and it's available. The PDF is on the web for free. Or you can buy his book, which is called Land of the Underground Rain. He wrote that in 1973, which is just a repeat of his dissertation. So spend the $40, buy the book if you want to, or go to this website. And actually, I think the dissertation is funner to read. It's the only dissertation I've ever read that's fun to read. It's enlightening, but it talks about the history of water in the Texas Panhandle from 1910 to 1960. And he wrote this in 1969, and he's saying how bad it is in 1969. How long ago was that? About 50 years, a long time ago. He was saying it was bad back in 1969. But let me read this out of the newspaper. It said it was the hardest windstorm the oldest inhabitant knows anything of. It just naturally blew and blew and blew and blowed and blowed and blowed and swept the country all up in one great big continuous sweep. Piled dust heaps everywhere. It sent dust through and into the tightest buildings, rattled the roofs, shook the fences, scattered the loose boards and boxes and barrels, and bent the trees, and roared and howled and shrieked and hissed till nothing else could be heard. It was frightful. If I would have wrote that in my English class, I would have got an F. It was said, sentence too long, break it up. But you get the point, don't you? But my question here is, when was this written? Now, the picture on the left is a picture out of the Dust Bowl. And I know if you're like me, you would read that and you go, oh, that's out of the Dust Bowl. But guess what? It isn't. This was written between 1888 and 1893. Now, you remember my graph. Let me go back to my graph. My graph went to 1895. That's the earliest that we had rainfall data. This is before that. And I've been calling this the early Dust Bowl. I don't know if that's a good name or what, but there is evidence of another Dust Bowl, not in the 1930s, but prior to that, in 1888 to 1893. So my question for you, is there a chance it's going to happen again? I don't know. I can't predict the future. But history says that 2011 was not that much of an anomaly. And so what are we going to do when we get 3 or 4 2011s strung together? I don't even like to think about it, but it's kind of like that warning of, if I were a financial advisor, I'd be saying, prepare for hard times. Save a little money up. That's what I'd be saying. I'm supposed to be an irrigation engineer, but I found that saving 1 or 2% on your center pivot isn't going to solve this kind of stuff. So this is what I'm preaching now is just beware. Know the history, know the variability of our climate. We live in hard times, and if you don't think it could happen again, how many times do you hear people say, well, it was dry last year, it's going to be good this year? We just think that way. I come from a long line of really unsuccessful farmers. My great-granddad, who traveled from Kentucky in a covered wagon and passed right through Amarillo Canyon area and kept going, looking for better. Too dry here. So where'd he settle? About 2 hours west of here, south of Tucumcari, where it's even drier. And my granddad, so my dad's dad, and I just get these stories from talking with my dad. My dad decided to go into ranching. He saw how hard it was being a dryland farmer in the plains west of here, where there's even less water. But my dad tells the story of, he doesn't talk about the 18 years growing up. He talks about the 1 year that they made a wheat crop. 1 year out of 18 that they made a wheat crop. And it was 49 or 50, and I went back and looked, and that was that summer, at least that 3 months, they had 16 inches of rain as opposed to average of about 7. So anybody can be a good farmer if you get that much water. But I remember asking my dad, and it wasn't meant to be like hey Dad, why was Granddad so stupid? I wasn't what I was trying to say, but why? I asked him, said, Dad, why did Granddad farm every year? And Dad said, well, because the belief was that this might be the year. I don't want to. You ever feel like that? This might be the year. I don't want to miss out on it. And so I'm going to struggle all those other years thinking that this might be the year. You look at data like this, and maybe we should have maybe we shouldn't be so optimistic that it's going to be better next year. Maybe we should be planning for this rather than what we hope. And it's good to have hope, believe me. It's good to have hope, but we need to have wisdom that goes along with it. Okay, I'm going to switch gears just a little bit, talking about history and talk about just some research that we've been working on. This is a no-till conference. I've been working with Dennis Coker. He's a county extension agent lives in Dumas, but he covers the four county area. And we've been working on a tillage study, research study at a farm, a commercial farmer up northwest of Dalhart, and we've got 2 years of data. I'm going to show you the latest year, but it's looking at 3 different treatments: conventional, no-till, and strip-till. 4 replications per treatment, large plots, 48-row plots. We also got soil moisture sensors in the center of each plot, Occupy, and I saw they've got a thing over here. You can go talk to them. I just want to quickly show some data. So you see the letters up at the top. Those are statistical indicators. So what this says is that no-till and strip-till were statistically the same. So even though the average was different statistically because of variability, they're the same. So no-till 228 bushels per acre, strip-till 225, conventional till 211. It was statistically different. Now last summer, Michael averaged 280. He's 280 bushels. Pretty good corn farmer, but he's got lots of water too. It's easy to be a good corn farmer when you got lots of water. This year, not so good. Why do you think that could be? Hail. He got hailed on twice, hard. And I actually thought he had lost this crop, but you guys that have grown some corn, you know that when it's still little, it can get hailed on and it'll come back. It just didn't come back. But definitely a difference between the conservation tillage and no-till. And I've been asking everywhere I go up in the northern counties, why do you think that is? I don't really know. I just know that it is. I don't know if it's related to water. I had one farmer that came and talked to me afterwards and said he thought it was due to germination effects, that the conventional tillage, because it had so much stalks and leaves and that had less probability of getting good soil contact with the seed. I don't know if that's true or not. If you guys got any ideas, I'd like to hear. I haven't looked at the soil moisture data, so I don't really know, but this is just kind of preliminary data that I'm presenting, especially since this is a no-till conference. Excuse me. One thing that was obvious is there was a difference in the number of ears with those tillage treatments. And the conventional tillage just had less ears, which may be related to that germination. Less ears, less plants that survived or germinated. And that's enough to make a statistical difference. One other research project I want to share with you. We were lucky enough about a year ago to be donated here at the university. A local farmer donated 23 acres to us that has water, and so we've actually got capabilities to do irrigation research, which is really nice. But we did a project last summer with a master's student, Leighton Greason. She's a farm kid from South Central Kansas. It's always nice to have those types of students that they already know how to drive a tractor. They already know hard work. And so this is her project. If you remember last spring, we went from being, this field was flooded. I'd never seen so many toads in my life. It was flooded about June 1st. We were finally, when the rain stopped, we were able to get out and plant on June 20th. And then what happened? It just turned bone dry. That's our climate, isn't it? It's either too wet or too dry. We had 5 irrigation treatments ranging from 0 dry land up to 2 inches per week with a surface drip irrigation. This is small plot type research. We got out there with the drone and took some pictures. I don't know how to do this, but thankfully I got some other guys that do. But you can see the actual experiment is on the inside. There's 20 plots that are on the inside. Ignore all the stuff that's on the outside. On the far left, that stuff that's real short, that didn't get any irrigation or fertilizer. It was just, it's overplanted is what it was. But the experiment is on the inside, and you can tell, looking at there's some big differences. I want to walk you through, here we go, walk you through some photos just through the growing season. And on the left, I'm going to have that treatment 5, that 2 inches per week. So on the left is going to be a lot of water. On the right is no water. We also put in these 3 different kinds of soil moisture sensors. I really like soil moisture sensors because they give you information that you wouldn't have otherwise. And in our kind of climate, it's amazing how a few extra inches of water stored in the soil can make or break you. Just a few inches. We got AquaSpy, Grow Guru, and then up there on the top right, some Acclima. Those are research grade TDR probes. Not near as they're very accurate. They're just not near as user friendly as some of the others. So stepping through, this is August 10th, and so we planted June, so this is about 2 months later. We had a very full soil profile. So on August 10th, there was not much difference between those plots that were getting 2 inches a week and the plots that were not getting anything, because there was just a lot of water there. Now let me show you, that's the 10th. Let me fast forward 2 weeks, August 25th. Now you see a big difference. Look at the height. Let me go back. Look how fast that forage sorghum grew in 2 week period. On the left, it's about halfway up that white pipe over there. 2 weeks later. But what happened to the one on the right? It just ran out of water. Now the nice thing about forage sorghum, and that's what when I talk to these corn guys, it's kind of like, this might be a good option for you. Sorghum is very drought tolerant, just like cotton is. And it doesn't just roll over and die whenever it gets dry, which is nice. If that were corn on the right, it had been dead. It had just been dead. Stayed alive, it just didn't keep growing. This is harvest date. That forage sorghum was about 7 feet tall. It grows good when it's got lots of water. The stuff on the right, dry land, again, it didn't die, it just stopped growing. This is, we like to see this. That's why I really like doing water research, because it behaves like you want it to. And it's like you don't have to be a rocket scientist to do this kind of research. It fits me real well. But just a linear difference in plant heights, just pictures of the heads. You know, the sorghum, the dryland sorghum didn't even make any head. I mean, it was, if it were grain sorghum, it would have been worthless. So the triangles are, this is a graph, or crop production curve, but it's a graph of yield versus water. So we do all of this research to get this one graph, which allows producers to make decisions based on how much water they have. And so the water on the bottom, that's irrigation plus precipitation plus initial soil moisture. Now in this case, we started with about 9 inches of soil moisture. That's a lot. It's rare that we have that, but keep that in mind if you're ever going to use this kind of data. 9 inches of soil moisture. Now the circles are the moisture adjusted. Forage sorghum is sold at 65%, most of the time adjusted to 65%. And because of that adjustment, there was a little dip, and I don't really know why, but that's research for you. And that's also why when we do research, we don't just do it once. We come back and do it another year and another year. We just keep learning. But this type of data is very, very valuable for those guys that are lucky enough to still have water, but they're going to transition away from corn. They just don't have enough water to grow good corn. This is an option. I want to show you some of the soil moisture data. So the red is the 2 inches per week. You see those 2 green lines? Those are the lines that AquaSpy and Grow Guru and all these commercial guys, I like them because they try to make it user-friendly to a farmer to just pull this up on your smartphone and look and see, are you keeping it in the green? If you're keeping it in the green, plant's going to be happy, going to keep growing. Well, look what happened. Even with applying 2 inches per week, we got out of the green real fast. Down there about September 12th, we went last summer, at least here in Canyon, we went from super, super, super wet, saturated, and it just turned off. And we didn't have a lick of rain until that peak when it goes back up about September 12th, and we got 3 inches. Problem was it was too late. Now, if you look at I showed you the average growing season precipitation, June, July, August. Now this is outside of that range, but last year, if you look at how much rain we got, it looks pretty good. The problem was it wasn't at the right time. It was too late. Again, if this were corn, even at the 2 inches per week, it wouldn't be good. Okay, I'm going to change gears just one more time. I'm not used to having so much time to talk. I want to show you a tool that we have developed. It's called a crop acreage allocator. It's just a spreadsheet. It's not rocket science, but if you look, it's a training tool kind of. And if you're looking at this and you go, hey, I'd like to play with that. I know how to use Excel. Just let me know, and it's free. You get what you pay for it. But if you look at things that we know, if you're a producer, what do you know going into the growing season? Well, you know how big your field is. That was an easy one. You know what your irrigation capacity is, how many GPM you got. You know if you have soil moisture sensors or a probe and you have experience with that. You know about how much soil moisture you have going into the season. Things you kind of know is expenses and revenues. You can look at, and I'm not an ag economist, so I don't really do this, but looking at futures, and you can contract your grain or your sorghum or whatever in the future, so you can pretty much know what you're going to sell it for, and you pretty much know what your expenses are going to be based on fertilizer costs and diesel costs and all that kind of stuff. Well, what do we not know? Growing season precipitation, amount and timing. And those are the worst things not to know, aren't they? It's how do you farm when you don't know how much rain you're going to get? Some people do it a lot better than others. If you still have irrigation, it takes that risk out, but precipitation is huge, as I'll show you here in a minute. So can we pull up that Excel spreadsheet? And again, this is available. If you want it, just send me an email and I'll shoot it right back to you. So the things in yellow up there are things that the user can input. If you're a farmer or producer and I've got 120 acres, I've got 420 GPM, growing season precipitation, let's say it's 8.5 inches. We're going to count on it being average. And I've got 8 inches of soil moisture. Again, if you don't like these numbers, you can change them. It becomes yours. This is for corn and fallow. It's just a training exercise, but corn expense, again, that varies from farmer to farmer, depending on age of your equipment. Are you even amortizing your equipment? And then the water requirement. Both of those are just linear relationships. These are based on numbers in the Northern Panhandle. about 37.5 inches to get 280 bushel corn, 28.5 inches total to get 200 bushel corn. And then there's a fallow cost. I was aptly reminded by a farmer just here a couple weeks ago that fallow is not free. And so, and you guys know that, you've got to either spray or something to control weeds. And so I put in, there's a number, $50 an acre. It may not be the number that you think is right. Put your number in. Let's do this. Can you change that groundwater to 700 GPM? Okay. So the chart on the right is just a comparison of all corn. It would be a projected revenue for all corn. Now keep in mind, this is not this year. This is last year when corn was, we've got $6.50 per bushel. It's actually up to $7 or something for a while. And it's not near that good this year. So again, this is training exercise. Don't think that I'm smart enough to tell you what you should be doing with your money. But if we've got 700 GPM, basically what it's saying is put it all to corn and make money, just like the good old days. Now, see where it says growing season precip of 8.5 inches? Can you change that to 2? And change soil moisture right below it to 2. So what I did is I just went to 2011 conditions. And what did it tell us? Well, if we knew 2011 was coming on, we would have been wise to only plant 100 acres of that into corn and leave 20 in fallow. But what the heck? I've got 700 GPM. I'm just going to plant it all. That's the thought process, right? And you would actually make more money if you knew 2011 was coming to plant less. That's the big if. Do you know? Okay, let's change that back to 420 GPM and put in the 8.5 on the right below, 8.5 and 8, yeah, 8.5 and 8. This is back where we started. And so with that type of water, we could still make good money if we got average rainfall. We would actually make more if we only planted 90 acres into corn. But let's look what happens when we change that 8.5, change 8.5 to 2, and right below it, 2 and 2. And this is what happened to the corn farmers, really what happened to everybody in 2011. If you look at that graph, we kind of got used to having average-ish rainfall, and then 2011 hit. And where it says here on the right, corn yield 129, it wasn't even that. In fact, most of the corn farmers just silaged, just cut it. They didn't have any grain at all. It was so hot and dry. If they would have known that was coming up, they could have put that amount of water on half of the field. Are you starting to see where I'm going from? I'm beating this to death, but very wise in years, I guess, crop consultant that I've been working with, who mainly works up in the north. He's just retired, but his greatest piece of wisdom was plan for the worst and adapt for the best. Plan for 2011. And when you don't get 2011 and you have more rain, adapt. Now, how do you adapt? Maybe you put half of it into corn and the other half you put into cotton. It's still, everything's risky, right? But if you think this is going, like my granddad, this is going to be the year. Be safe with half of it and risk the other half. Go ahead and change that groundwater to 200 GPM. And then we'll go back to 8.5, and 8. Just study that for a minute. 160 bushel corn, that's not too bad. Now let's go to, and you made some money doing all corn, $35,000. This was, again, 2 years ago. Change those back to 2 and 2. On the right, it's actually a negative number. That's why there's all the asterisks, but lost $89 per acre. And really, we wouldn't even harvest if it was predicted 52. This is the thing with math. We probably wouldn't make 52 bushels an acre, and we wouldn't even harvest it. But if we had that money, if you're still insistent on being a corn farmer, just plant 30 acres instead of 120. I've got, we're not going to take time to mess around with it, but with that forage sorghum curve that I showed you, in this same spreadsheet down at the bottom, there's a forage sorghum fallow. I've got a spreadsheet for irrigated corn, dryland cotton, and irrigated corn, irrigated cotton. And everywhere I go, people are like, well, can you add this? Can you add that? And it's like, well, we'll get to it. But the point right now and for today is I kind of wanted to show you, tie in, remember those graphs of how variable it is, and then a very simple calculator like this. If you put those two together, even if you're not a farmer, you can pretend you're a farmer and start realizing how hard it is for these guys. It's hard. I don't like the word gambling, but I have so many farmers say you can use that. That's what we're doing. Especially if you're not planning ahead, planning for, I don't want to say the worst, but planning for conditions that aren't average. Did you know, statistician in me, half of you guys, half of everybody in this room is below average. Half of you are. If I took the average IQ out here, half of you guys are below that. That sounds kind of negative, doesn't it? But that's statistics. Half, it's just statistics. We get 8.5 inches of rainfall, it don't mean nothing really. What's important is the year-to-year variability, and it can range from 2 inches to 16 or 17 inches.
Dr. Parker, I do want to ask one question of you. On the experiment that you did this last year with the forage sorghum, you said it rained a lot, the beginning. Mm-hmm. It kind of started off. Was it a full profile of moisture? The soil was holding as much water as it could hold.
Yeah. It was as full as it can get, because like I said, it was saturated, and we had I'd never seen so many toads. It's kind of like the plague of toads is what I felt. There were toads, but there was enough standing water that there was tadpoles and toads, but when it shut off, it shut off. But yeah, it was full. It was wet. And I guessing 9 inches, it may have been even more than that. But we don't get that much soil moisture all the time. That's, usually 2 or 3 inches is more common. So, but this type of research, I need to make that clear so, a producer doesn't come and say, well, I'm going to use that graph. That graph doesn't work if you've got 3 inches. 6 inches of soil moisture is huge.